All right, clip number 2 for our final exam cheat sheet. In this clip, we're going to start with problem number 3 and pick up where we left off. Problem number 3 introduces chapter 3. In chapter 3, we are first introduced to what are called quadratics. Quadratics deal with this x squared element, and in chapter 2 we talked about polynomials, and this was part of polynomials. This is a polynomial phrase. But quadratics, like this x squared, when we deal with a function like this, it's going to have a specific shape. Here's just where I'll remind you, it's not totally critical to this problem, but an x squared quadratic will have a U shape, whether it's a happy face U or a sad face U type of shape on a coordinate grid. Valuable to know a general shape because that's going to help us actually with understanding what our results are going to be for this problem. Right? In our first semester final, this kind of problem involved identifying some key features about the visual graph and then graphing the results and all that kind of stuff, filling out an XY table. This is going to be condensed down to identifying 2 visual pieces based on this function. Okay? And those 2 visual pieces are going to be as follows. Identify axis of symmetry. Axis of symmetry is just an abbreviation. And you're also going to be asked to identify the vertex. So just to point out, you don't need to write this part, but just to point out visually what we're identifying, you will not have to graph this visually, but just to identify what each of these pieces is, just to remind us from chapter 3 what they are. This parabola will end up looking roughly like this once it's been graphed on a coordinate grid. An axis of symmetry is what splits this in half. Because this is a symmetrical U shape, it's the same on both sides of this axis of symmetry. An axis of symmetry is going to be some vertical line that splits this U shape in half. That's what an axis of symmetry is. The vertex is basically the interesting point on this U shape. Namely, it's going to be, in this case, the coordinate point that makes the extreme low point of this U shape. So axis of symmetry will be a vertical line that will be expressed as x equals some number. So we'll go through that process in a second. And vertex will end up being a coordinate point that will be the location of what we call the interesting part to a parabola. Okay. So again, you didn't need to draw that part. Let's just go through how to solve it right now. So for axis of symmetry, there was a simple equation that we used based on this result or this initial function. And the equation here for axis of symmetry is that negative b over 2a will give me the axis of symmetry. So what are b and a in this equation? Well, here's where I'll remind you that the standard form of a quadratic has the following coefficients. A is going to be whatever value is multiplied by the x squared. In this case, a is going to be positive 3. That's what's going to end up going down here. B is whatever coefficient is attached to just x. In this case, the negative 6, and that negative does matter, but the negative 6 will end up being what I'm plugging in here. And I will have to keep track of that negative sign too. We don't necessarily need it in this equation, but C is going to be whatever number doesn't have any x attached to it, and that's the positive 5 here at the back end. Again, we don't need it necessarily for axis of symmetry. All right, well, let's just plug this stuff in directly. All right, I always take the time to write that negative sign just in case I get exactly what happens here. So B here is this negative 6, so that negative 6 up there. So that's a negative 6. All over 2 times A. A here is that positive 3. Okay. I simplify this. Negative 6 is positive 6. 2 times 3 is 6. This right here is technically my axis of symmetry. This does reduce to 1. This 1 is my axis of symmetry. How is that expressed? I would write the equation x equals 1. X equals 1, if I were to graph that, that is a vertical line 1 unit to the right of the origin of the y-axis, right? So this vertical line is what splits that U shape in half. A valuable visual piece of information for this quadratic. Well, great. There's finding the axis of symmetry. That's the first part of this problem. The next part I have to deal with is finding the vertex. The vertex, again, is a coordinate point. And so for a vertex, I should have, let me use pink again, I should have some coordinate point results, some x, y coordinate point. Well, the axis of symmetry, this x value, is actually what's going to go right here for this x value. So that 1 that we just got for axis of symmetry gets pulled right over here. So if you got -4 would go in this x spot. Now, how do I solve for y? As with any xy table or any function, anytime I have an x value, I can plug it directly back into my original function, and it will spit out some y coordinate point that pairs up with it. So essentially what I'm going to do here is I'm going to plug directly back into this equation this x value, whatever I get here. So my equation is 3 times x squared minus 6x plus 5. So 3 times x squared minus 6 times that x plus 5. It's just that equation, and I'm going to be substituting in for that x with that value. All right, so now I just plug in that value. Again, in this case, we got 1. It won't always be that case. Your number will likely be different on your final exam. And now I just do the math. I would do these one chunk at a time, and then just do the arithmetic at the end. So let's focus on this guy right here. 1 squared, I have to do that first because of the exponents in my order of operations. But 1 squared, or 1 times 1, is 1. That 1 times 3 gives me 3. So what's 3 times 1 squared? It's 3. That's this chunk. Next chunk is this. -6 times 1 is just simply -6. And then the plus 5 is exactly as it's written. Well, this is just simple arithmetic now. Just do it in order. 3 minus 6 gives me -3. Plus 5 gives me +2. What's the significance of this result? After I plugged in that x value of 1 into the function, it spat out 2. 2 is the coordinate pair with that 1. So my vertex is located at 1, 2. So if I were to go right 1, down 2, that would be the lowest point of my U-shaped parabola. And that concludes problem number 3. I'll go ahead and stop the recording right there and pick up in clip number 3 with problem number 4.